In this video, we'll walk through a simple data workflow using Excel tables and pivot tables. We'll start from a simulated sociological study using a simple Python script to generate some raw data, and then we'll import that data into Excel, structure it properly using tables, and then we'll pull insights from that data using Excel's pivot table feature. To start off though, we need to generate some data. So imagine we're conducting an experiment to study human memory. We've recruited a group of participants and divided them into 3 groups, each assigned a different study method. So Group A will use flashcards to study, Group B will use audiobooks to study, and Group C will use online videos. Now each participant practices some tricky subject using their assigned method, and then takes 3 memory tests, spaced out over time. We'll call these trials 1, 2, and 3. Each test is scored out of 20 points. If a participant scores 15 or higher, then they pass, and any lower than that, then they fail. Now, normally we'd be in a lab handing out tests and monitoring our participants as they take them, and then grading everything by hand. But for the sake of this video, we're just going to simulate this data collection with a Python script. So this script simulates our memory study. Participants will use different study methods, whether flashcards, audiobooks, or online videos. We've set it up to use 90 participants, and each participant uses one of those study methods and then takes 3 trials. Scores are generated randomly as numbers out of 20, where anything above a 15 is considered a pass and below that is a fail. Now these numbers simulate our participants taking these tests to validate their memory of whatever subject they're studying. Below this, the main function sets up a big list of study results and then prints it all to a file. For each participant, we're going to select one of the study methods, and then we'll generate 3 trials per subject. And then for each trial, we'll generate a score. Then we'll grade whether that score is a pass, and then write down a line in our results, which records all of these details. We then take our list of results and write them all into a plain text CSV file, first the header row, and then each of our data rows. So when we run this script, it generates all of the data we need and writes it all into a CSV file. So let's try that out. So we run our code, and here's the result. 270 rows of simulated study data ready for analysis. Now let's open this data in Excel. Now, the first thing we get when we open in Excel is a warning that we had leading zeros in our data. It's not really going to affect our outcome here whether our study participants have 1s or 001 as their ID. So I'm going to say don't convert. And now since this is a CSV, let's save it as an Excel file. So save as. Switch the type to Microsoft Excel, and save. Okay. Now at first, this is just a grid of data with no real structure or formatting, just raw, plain text inside an Excel sheet. Most real-world data starts out flat and messy like this. There's no formulas or formatting to help us make sense of any of it. Excel doesn't even technically know that the first row is a bunch of headers that are distinct from the actual data below it. So let's fix all of that by turning this data into a table. So tables in Excel are a way of taking a block of data and telling Excel that it's a cohesive unit. A given worksheet can have multiple tables depending on how you're using your data, though here we'll just turn it all into one big table. So to create a table, we highlight our data, go to the Home tab, and click Format as Table. Pick whatever style suits your preference. So I'm just going to use a little black and white table here. And a little dialog will pop up to confirm your selection. Make sure the values are correct, it has the right range, and that the My Table Has Headers checkbox is selected. Click OK. And just like that, we now have an Excel table. You might notice a few things right away. Our first row is now marked and formatted as headers. Each column header has a little drop-down menu button, which we'll look at in just a moment. And depending on which style you picked, the rows may now be banded with alternating shading for easier reading. Also, the column widths all automatically adjusted to fit our data as well. But there's even more happening under the hood. Excel now recognizes this table as its own entity, rather than just a grid of independent cells. Now each row corresponds to an individual record, and each column a single consistent field. Any formulas added into one cell get automatically filled down for the whole column. And if we add a new row to the bottom, below our table, the table will automatically expand to include it. Tables behave like smart containers, automatically adjusting as our data evolves. So let's play with some of the new tools that came for free when we format as a table. So you'll notice every column header has a little drop-down arrow. If we click it, we get a little menu which contains sorting and filtering tools. This is similar to sorting and filtering in Excel without tables, but it's made a bit simpler because Excel assumes each whole row is a single unit. For example, if we click the drop-down on the study method column, we can sort our data alphabetically by this column. Or we can do the same for any other column, whatever helps you focus on the information that you care about. There are also filtering options, so for example, we can filter our data to just look at the results from trial 1. Note, by default, all the values are checked on, so if we uncheck these values, they'll be filtered out of our visible data, and now we're only looking at trial 1 results. Filtering is temporary, though. It's not deleting that data, it's just hiding the extraneous data so that we can focus on just the slice that we're interested in. We can also stack filtering or sorting operations across multiple columns. For example, we can view just those records which passed on trial 1 by adding a second filter. Or if we clear our filters, so select all in both of these columns, we can stack some sorting operations. So for example, we can sort all of those who passed on trial 1, bring those to the top of our list by sorting on pass-fail first. Pass-fail will be this way, and then on trial 1, sort smallest to largest. So notice it's all trial 1s first, and it's all the passes, and if we scroll down, we get all the fails from trial 1, and then all the passes from trial 2, and then all the fails from trial 2. So now all our data is sorted by trial number, but with ties sorted by pass-fail. So sorting and filtering in tables is quick and easy, and at times really helpful. Next up, one of the most useful features of Excel tables fixes one of the most difficult challenges of Excel formulas, which is a lack of variable names. So trying to create Excel formulas, particularly complex ones with many references, can be a real headache when trying to remember which column letter corresponds to which data header. With Excel tables, though, we can assign a name to the entire table and then refer to that table and each of its columns with names instead of cell ranges. So in the ribbon menu, with the table selected, there's a new Table Design tab. And right at the start of that tab is a text field that says Table Name. So here our table is currently named Table 1. And we can change that to whatever we like. We can also just leave it as table 1 and use that as our variable name, but as soon as you have multiple tables, you're going to want more meaningful names. So let's call this the study data. And now, when we want to make a formula that considers data in this table, we can use the name study data. For example, if we wanted to average all of the test scores, we'd normally have to write something like equals average, test scores are in column D, so we'd say D2 down to D, I think it was 271. And I have to remember exactly how long that column is, and if I added more data, I'm going to have to update this formula. Instead, we can now write equals average, and then the name of our table, so study data, and we can see it's already suggesting the name study data for us. If we hit tab to autocomplete, we don't even have to type it all. And then if we want to average the test score column specifically, in square brackets, we include the name of the header. So again, we can use the arrow keys and just select test score and press tab to complete, or we could type it in manually. Close our brackets, and that's our function. So the name of our table, and then in square brackets, like with a Python dictionary, for example, we write the column header name. It has to be the exact column header name. If there's a space in our name, then we have to use quotes to include that space as well. In this case, it's all one word, no spaces, so we can just say test score. Now, this might be slightly more typing in this instance, but it's also much easier to interpret. And as an added bonus, if we add more rows to our data, our table is going to automatically expand, and this formula won't need any adjustment because it's already averaging the entire column. So having clear names can make the difference between a functioning Excel workbook and a grid of incomprehensible nonsense. So I'd also just like to point out here that you can define variable names in Excel for other things too. If you go to the Formulas tab, there's a button called Name Manager. If we click this, it gives us a list of all the variable names that have been defined in this workbook. For now, that's just our table. If we hadn't renamed it, this would just say Table 1, but since we changed it to Study Data, we can see Study Data has all of its values and it refers to a specific range in the entire workbook. We can create new variable names that refer to other cells or entire ranges. To do so, we click New, type in the name that we want. So I'll say average score, for example. And we'll make that point to the cell where we just calculated our average test score. So that's K3 in Study Data. So under refers to, we can set that reference to K3 or wherever you want to put your variable. This can also be a range of values if you like as well. Click OK, and then we can use this variable in any formula that we wanted to. So for example, I can come over here and say equals average score times 2. And that just multiplies that variable by 2. And notice when I highlight this, it knows exactly where average score is pointing. It's cell K3. So again, it's just a variable name in place of a cell reference, but that makes your formulas a lot easier when they get way too complex to remember where all the cell references are supposed to point. So we've seen Excel tables now, and we can sort and filter data and build smarter formulas. But even with all these improvements, we're still looking at raw data row by row. If we want to answer questions like, what was the average test score for each of the different study methods, or did participants improve across the 3 trials? Then we need to aggregate this data to summarize it quickly and rearrange it without necessarily writing out a dozen separate formulas. And this is the idea behind pivot tables. A pivot table lets us drag and drop fields to quickly reshape how we view our data, all without writing any formulas at all. So step 1, click anywhere inside the table. Then up in the Insert tab in the ribbon menu, we can create a new pivot table. This will bring a little pop-up asking us where we want that pivot table to live. Usually a new worksheet is the cleanest choice, so we'll leave it set to New Worksheet and click OK. And this gives us a blank pivot table. Notice we're now in a new tab, Sheet 1, where our study data was on the first sheet there. So our blank pivot table is on the left here, and on the right we have a panel called the Field List. The field list is the control center for building a pivot table. It shows all the fields or columns from our study data table. And then down here are 4 areas where we can drag the fields to automatically build the pivot table. These boxes are called filters for applying filters across the pivot table, rows for grouping data vertically, where each category is the header of a row, columns for grouping horizontally, where each category is the header of the column, and values for calculating things like sums or averages. Now, pivot tables may seem daunting at first, but there's a simple sort of magic afoot, where all we need to do is drag fields into these areas, and Excel will generate the pivot tables for us on the fly. No formulas needed. So let's build something simple and meaningful with our data here. Let's find out what's the average test score for each study method. Since we want to group our data by study method, we'll start there. We'll drag the study method field into the rows box. And notice that we now have the study method categories listed as row headers in our pivot table. If we put them in the column box, then they become column headers. We want them as row headers though, so let's put them back there. Next, we want to know the test score for each of these different categories. So we'll drag the test score field into the values box. And notice that now our pivot table contains the sums of test scores for each of the different categories. Pretty easy to do, but for this question we wanted the averages, not the sums, so let's fix that. So in the values box here, click on the drop down of the sum of test score and select Value Field Settings. This brings up a new pop-up menu with options for this specific field. Here we can change the title of our pivot table column if we want, and change how the values are aggregated or displayed. So let's change the Summarize Value Field by Average. Do that and click OK. And now our pivot table shows the average test scores for each study method across all trials. We have a separate cell of aggregated data per each category, and now we can easily see which study method produced the highest average scores. In this case, flashcards. Note that we could accomplish a similar result using just tables and some formulas like average if. However, the ease with which Excel can do this with this interface makes pivot tables a highly practical tool to have on your Excel tool belt. With just a few clicks and no formulas, we answered one of our big data questions. Next, let's answer the question, did participants improve their test scores across trials 1, 2, and 3? This time we don't just want to group by study method, we also want to compare scores across individual trials at the same time. If we want to keep our previous pivot table, we can just click elsewhere in the sheet and insert a new pivot table. If we enter our table name study data as the data range, so Excel knows where to draw our data from, and for the location, Excel will assume the cell that we currently have selected, which is fine. So that's in the pivot table sheet in cell D3. So click OK, and now we have a new pivot table. Now, just like before, we still want to see our results for each study method displayed separately. But now we also want to see each trial side by side. So we drag the trial number field to the columns area. Now we have an empty grid where each cell is an intersection between a study method and a trial number. Instead of just a single column of averages, we have a column for each of the trials side by side. So let's fill this with data and drag the test scores field into the values area. Excel will want to do summing again, so if we want the average, then like before, we have to go into the options, click the drop down, value field settings, and switch that to average. And now we have the average test score for each study method broken down by trial. Each row is still a study method, but now if we read across each row, we can compare how each method's scores changed over time from trial to trial. Are scores going up from trial 1 to trial 3? Are certain study methods improving faster than others? Is there a method that doesn't improve or even degrades performance over time? With just a few clicks and drags, we've pivoted our view from a big pile of scores to a trend across time. Now again, this data is simulated, so the insights that we're gathering are maybe not super meaningful, but the means by which we're gathering them are reproducible with real data, which could be meaningful. Next, let's answer another common kind of question. What's the pass rate for each study method? This time, instead of looking at calculated test scores, we want to look at counts of passes or fails for each group. So let's start another new pivot table. Now, we want to know for each study method, what is the pass rate? So we'll again start by dragging the study method field into the rows box. And then we can put the pass-fail field into the values box. And this gives us a count of the pass and fail values per category. Now, since pass and fail data isn't a number, Excel can't do sum or average, so it defaults to counting, which is what we wanted, but it's counting both passes and fails together. So what we're really getting is just a count of how many records there are for each study method category. So let's fix this. We might try to use columns again. So if we drag pass-fail field again, but this time to the columns area, then we can see how many passes or how many fails per study method. So we can see, for example, that we have 29 records which used audiobooks and failed, and another 13 records which used audiobooks and passed their trials. From this, we can interpret what the pass and fail rates are, but let's go a step further and make our pivot table tell us explicitly. So if we're only interested in the rate of passes per study method, a way to accomplish this is to use a filter. So instead of using pass-fail as our columns, we'll use it as a filter instead. So drag it out of the columns area and drop it into the filters area. So now we have our categories as rows, which counts again everything, both passes and fails into a single number. But we also have a filter box above our pivot table. If we click that and set it to just the pass value, then we get counts of just the number of passes per study method. If we want to see the rate of passes, that is the percentage of trials per study method, which ended in a passing score, then we can update how the pivot table displays our value. So we can go back into the value field settings menu. So down here, count of pass-fail, pull the drop down and go value field settings. Here there's a second tab called Show Values As, which is for changing how Excel displays these values in our pivot table. If we click on the drop-down that currently says No Calculation, it has options that are mostly for displaying these values as proportions of various different totals. Here we're interested in the proportion of passes per study method, and since the study methods are currently our row headings, then we'll say the percent of row total. Click OK. And now instead of seeing the number or the count of passing trials, now we see the percentage of passing trials. However, when we filtered this category to only pass, Excel removes all of the fail data from the pivot's working data set before it calculates anything else, including totals like this. So when we ask Excel to show the percentage of row totals, it divides the pass values by the total, which is also just the pass values, and thus everything equals 100%. To fix this, we can take our pass-fail category and put it back into the columns area, and now we can see the percentage of trials that are pass for each of the different study methods. And that wraps up the basics of working with Excel pivot tables. We've seen how to drag and drop fields to group, subgroup, and summarize data, and to calculate rates or percentages, all without typing a single formula. This video, though, only really scratches the surface on what pivot tables can do. But even just knowing how to build simple ones like these already gives you a ton of options. Now, once you've built your pivot table and you're happy with the structure, it's usually a good idea to spend a few extra clicks to clean it up. You can apply a style to your pivot table in the Design menu tab. You can format your numbers properly to limit the number of decimal places in your averages, for example. Or if you like, you can rename any of the awkward labels. A clean and polished pivot table is easier to read, which makes it more valuable for presentations or other displays. In the real world, it's not just about doing the analysis, but also making that analysis clear for your audience. And remember, you don't need to memorize every single menu and option. You just need to know that these tools exist so that you're capable of picking them up when you need them. Excel power users aren't necessarily the people who know every hidden secret about the application. They're people who are willing to explore, experiment, and learn from their mistakes while solving real problems. And that brings us to the end of this video, and also the end of the course. If you've made it this far, then a big congratulations on sticking with it, and an even bigger thank you for your time and attention. If you've enjoyed these videos or have any feedback, please feel free to leave a comment. I hope you all learned something, and I will see you at the exam.